guys, so I'm going to take a couple minutes to go over the day 2 functions notes. So on this day we talked about linear versus non-linear functions. So a linear function is a function that will make a straight line when it is graphed. An equation is linear if it can be written in the form of y equals mx plus b. So remember, that's our slope-intercept form where m is the slope and y, I'll try to use my mouse to point, b is the y-intercept. So remember, if b equals 0, it could also just be in the form of y equals mx without a b. That's still the same form because that would be like y equals mx plus 0, and you don't have to write the plus 0. So a table is linear if it shows a constant rate of change throughout the entire table. So in the notes, it says the following it's a little cut off there, but we use functions to fill out a table of values and create a graph. Look for any patterns among the functions that are linear and those that are nonlinear. So for this one, it gave us the equation y equals x squared plus 1. In the table, there are x values. We would substitute each x value in the equation to get the y value. So for example, y equals, if we use -2, okay, y equals -2 squared. -2 squared is -2 times -2, which is +4. Plus 1 is right here. The output, or that would equal 5, y would equal 5. So that's why we got 5. Okay, we would do the same thing for each value and get these y values. Okay, then we would just graph. So we would graph each coordinate. Remember, x and y are our coordinates. So this would be the point -2, 5. So I would go to -2 and then go up 5, and that is the first coordinate point. The second coordinate point is -1, 2. So I would go to the origin, go to -1, then go up 2, and that's the second coordinate point. When we plot all 5 of these points, we get what's called a parabola, and this is nonlinear because it's not a straight line. Obviously, it's curved, okay? It's not a straight line. So is the function linear? No, the graph is not a straight line. There's no constant rate of change. Now, for this one, I'm not going to spend too much time talking about it, but it's the same idea. Substitute the x value to get the y value, and then plot the points. Okay, so yes, this graph is a straight line, and the table shows a constant rate of change. Okay, so for every 2 change in y, right, this is a +2 change, there's a +1 change. A +2 change, a +1 change, a +2 change, a +1 change. There's a constant rate in this table, so that's another reason that it is linear. What do you notice that is different about the functions in questions 1 and 2? So in question 1, the x has an exponent. In question 2, it does not. So if it's squared or cubed or to the 4th, it is not going to be linear because you're going to get these different nonlinear graphs from that. Whereas if it's something just like 1/2 times x, not raised to an exponent, it's going to be a straight line, so it's linear. Okay, so for notes part 2, okay, you should have continued doing that same process for each. This gives you kind of a wonky shape here, so that is not linear because it's not a straight line. If you connected these, this would be linear, so it's a straight line, and then this would give you sort of like a curved line right here if we connected these, so that's non-linear. So again, the equations that were linear could be written in the form y equals mx plus b. The equations that were nonlinear, again, this one was raised to a power, and this one had x in the denominator. If x is in the denominator, it's also going to give you a nonlinear. Okay, I hope that was helpful. Please let me know if you guys still have questions.